Hello and welcome to Chemistry Nuggets, where you can polish your knowledge and clear the. Friends, today's video is question number 2.17 from NCERT textbook class 11 and the chapter name is Structure of Atom. So let's find the question. It's question number 2.17. Calculate the wave number of the longest wavelength transition in the Balmer series of atomic hydrogen. So friends, we need to calculate actually the wave number. But before that, we need to find first of all what is Balmer series and then which is the longest wavelength transition. So come up to Balmer series. When there is a hydrogen atom and these are the energy levels 1, 2, 3 and so on like that. And the excited state of the hydrogen atom, the excited electron is from infinity or from any energy level. When it is dropped to the energy level number 2, when it is going to n final is 2, then the lines which are created, those lines are called Balmer series. So understand Balmer series, when the excited electron from any higher energy level drops to the energy level number 2, the lines created are, those lines are called Balmer series. Now, so it means the final state of the excited electron will be in the energy level 2. Now we will let's understand longest wavelength. This we will understand with the help of the equation E is equal to h mu. In this equation, E is the energy, h is the Planck's constant and mu is the frequency. From this equation, we have a relation between energy and the frequency. E is directly proportional to mu. It means if the energy is increased, frequency will be increased, or if the frequency is decreased, energy will be decreased. In the same way, we have one more equation. We have one more relation between frequency and the wavelength, lambda. The relation is mu is inversely proportional to lambda wavelength. It means when frequency is increased, lambda will be decreased, or when lambda is increased, frequency will be decreased. So from these two relations, we can create one more relation between energy and the wavelength. It will be E is inversely proportional to wavelength. So we can say if energy is increased, wavelength will be decreased and vice versa. Using this relationship, we will find the longest transition when it will happen. So if energy in increase, when will be the energy is the highest? When the electron coming from excited electron is in infinity and it is dropped to n is equal to 2, then the energy difference will be the largest because the distance the electron traveling is the largest. So energy difference is the largest, and that's why the wave number according to this relation the wavelength will be the shortest. So suppose n initial will be infinity and n final will be 2. If this case will be there, then energy difference will be the largest. So that wavelength will be the shortest. So we need a longest wavelength. It means we need to make the energy difference smallest. When will be the energy difference smallest? When the distance is smallest. So if if n initial, it means the excited state of the electron is n is equal to 3 and it drops to the n final state will be 2. Why it is 2? Because we need to create the Balmer series. So if electron is jumping from n3 to n2, that distance is the smallest distance. So the energy difference also will be the very smallest, And if the energy difference is smallest, the lambda, it means wavelength, will be the longest. So here energy difference is the smallest. So lambda means wavelength will be the longest. That's why we will use n initial, means n electrons starting point is n3 and ending point is n2. Now after getting these 2 points, we are going to calculate the wave number. The formula for wave number is mu bar, or we can say 1 by lambda also. It will be minus 1.097 into 10 to the power 7 in brackets 1 upon n final square minus 1 upon n initial square, and it is multiplied by z square. Here n final is the n2 or n initial is the n3, and z is atomic number. For hydrogen atomic number is 1, so we will put 1 here. Now let's start putting the values. It is minus 1.097 into 10 to the power 7 in brackets 1 upon, and final is 2 square minus n initial is 3 square, and in place of z we will write 1 square. Minus 1.097 into 10 to the power 7 in brackets 1 upon 4 minus 1 upon 9, and 1 is nothing. Now first we will solve within the brackets. It will be 36, 9 minus 4, it will be 5 upon 36. So we can write minus 1.097 into 10 to the power 7 into 5 by 36. So after doing all the calculations, we get the answer here, minus 1.523 into 10 to the power 6 per meter. The unit of wave number is per meter. Now this is the final answer. So friends, question is very easy, just need to understand the concept. So please like, share and subscribe the channel so that you will be there with us for the next coming video. Till then, thank you.